Okay, welcome to Digital Forensic Essential course, and we will be talking now about model number 4, which is related to data acquisition and duplication. Last model we have seen about disk, all right, how different type of disk, what are the disk driver, how the system boots, in different operating system like Windows, Linux, Mac OS. And then we also understood how to recover files which are deleted, all right, using different tools we have used to understand how you can recover the deleted files. Do you remember any terminologies? We call some of them is where the files, the location is stored in the hard disk. What is called? Can anyone tell? Or the boot system is stored? Can anyone type? Exactly, Sayed. It's called master boot record, MBR. Excellent. Yeah, I can see many people are typing. It's excellent. Yeah, it's called master boot record, something which is very important in any file system. If you want to really recover files, if you want to analyze files in a hard disk, then this is something which is going to help you to understand. Okay. So now today we are going to talk about different topic, which is about how data acquisition happens, right? And different type of acquisition and also the format and the methodology used to acquire data. So if you want to analyze any incident, any forensic incident, collecting data is very important. Do you agree? If you are not able to collect proper information and also understand its type, and also you format the data in such a way that it's understandable, then it is very difficult to use the data as an evidence in the court of law. All right, it will be difficult to use that. So let us understand now the data acquisition fundamental. Okay. So what is data acquisition? When we talk about acquisition, the word itself talks that it is something we take over, is it not? So it's something, an established method where we want to take or extract the information which is stored electronically. We call it ESI, electronically stored information, from the suspect computer or storage media, in order to know the what is happened during the crime or during the incident. So as a forensic investigator, you should be able to verify the accuracy of the acquired data. When you collect data, you should know that is it correct, or are you taking something which is duplicate or fake or modified, all right? And that will help the investigator to complete the process, should be auditable and acceptable in the court. So tomorrow they're saying that, okay, I want to audit, or I want to, if the court has to accept the data, whatever you're going to present, that means it's very important that the data has to be something which is, acquired, something first of all acquired properly, then formatted and presented. So different type of acquisition happens. One is called live. For example, when your mobile is on, when your system is on and I try to collect information, that is called live acquisition. So the other one is when you closed your system, there is nothing working, for example. So now I want to collect information from your system. Your hard disk is powered off, your mobile is powered off, but I connect through some means to extract the information. Maybe I just remove the hard disk, connect to my a computer and try to copy the data. So it requires both. One is called live and data acquisition. There are data acquisition is also called as static one. So live data acquisition involves collecting volatile data from a live system. For example, the data I collect it could be changed, or it is of the nature of dynamically, keep changing. So there is something volatile. So it helps in determining the logical timeline of the security incident. For example, what time it happened, when it happened, who was there, who is the user responsible for this data, all of them. So once you collect the live information, then you can also follow with the static acquisition, which we call as dead acquisition, where an investigator then immediately shut down and removes the hard disk and then acquire in its forensic image. We will go and put it and then dump it and take the information. Right. So two type of data. One is system data, like how much memory is running, used, what are the DLS or libraries which are active at this point of time. Is it who's logged in currently? Because I want to know somebody's hacked my system. So how do I know that somebody has hacked? So maybe I need to analyze the files, or I need to analyze that if any logged on users are there, maybe who are not authorized. So we need to find all those information in order to make sure that this is proper. Okay. Then in network data, maybe I'll try to get routing table, ARP cache, configuration, connections. Why do we need network connection, or let us say routing table? Can anyone tell? These are live information, am I right? I'm collecting it. So why do I need from investigation perspective, what are the connection which is live at this moment in my PC or my mobile, my server? Why do I need that? Yeah, you get it. You get the IP address, exactly, Kamalesh. But why do I need that? Why do you need to connect that? Because I need to know, is there any live connection which is pulling data from my hard disk, or which is trying to modify something, or maybe I have not opened that particular application, but this application is running in the background. Okay. Do you think that I can know what kind of connections are there after the system is shut down? Do you think I can get what type of network connections are there after I shut down the system, or after I, power off the wireless network or pull out the Ethernet cable? Do you think I can get it? What do you think? Yes, no, I'm right. I cannot get it. So it's important. Sometimes it is, we need to see that, simulate the situation and make sure what is happening. As long as you get something live, it's good. If not, sometimes we ask we create that environment by simulating, what could have happened when somebody hacked the system, when malware was injected. So I need to install the malware, simulate and see what are the connections it is making. We normally do it in an environment called, do anyone know? Where do I simulate such kind of things? This environment is called, or the methodology is called is what? Sandboxing, development, not development, sandbox, all right? So I create something and sandbox environment, exactly, and try to see what's happening when this code is running. It is called dynamic testing, right? Static is something when we know that nothing is running, but dynamic means when I execute the particular code, particular malware, or some kind of Trojan when it's there, or worm, how it is creating an impact. So now all of you understand why do we need live data? Do you understand the importance of that? Yes or no? Yeah. Very good. So let us get into the next. What is the next one? We need to make sure that the order of volatility. Yeah. So when collecting evidence, and investigators need to evaluate the order of volatility of data depending on the suspect machine and the situation. For example, this is something RFC 3227. They're saying the order by which you should take it. For example, the register and cache, the first one. Then routing table. Third one is temporary system files, disk and other storage media, and remote logging and monitoring data, physical configuration, and archival media. So if you are not taking the registers and cache, maybe when you restart, when you shut down the particular application, maybe the cache and register may go because it is volatile in nature. Do you understand? Why? See, when you go and see so many data, where you should focus. So you should focus with the data which could be easily, erased, or which could be easily removed because of you restart, or maybe you wipe off, you shut down, maybe you close the particular application. So try to take that information at first. Then you go to routing table, temporary system files, one by one, till you go to the archive media. Archival media, it will be there. Most of the time, it will not be, impacted. So what is then data acquisition? Is defined as the acquisition of data from a suspect machine that is powered off. So it should be powered off. So what kind of storage device you can think about when we called about dead machine? Can you type some of them? I just moved it purposefully, but I want you to type what type of what type of device will a removable hard disk, pen disk, USB. Very good. Then that's all. Okay. Yeah. So flash cards, smartphones, all of them, right? So static data is like you go and analyze the email of the person. Maybe there is a Word document, or you have a chart from the web, WhatsApp or Slack or any other communication media. Right? And also various deleted files. You want to check why it was deleted. It could be in trash, right? So these are the things which normally, you need to look at for data acquisition. Okay. So rule of thumb, what is the rule? When you are acquiring data, when you're collecting data, what is the rule you need to follow? Okay. The first one is, do not work on original digital evidence. Why? Because if you are working on original evidence, what could happen? If you work on the original, maybe by mistake, you deleted that, right? By mistake, not by intention, you deleted, modified. Yeah, you may correct. So tomorrow, if you go to the court, yeah, they find that this information has been altered. Yeah. Do you think they will accept in the court? Do you think they will accept? No, am I right? So always make sure when you collect the data, don't start working on the original data and trying to fiddle with it. No, take a copy, logical image, and then start working on that. That is one thing. And also the second one is, if you want to store that, yeah, metadata is modified like date of creation. You are exactly right for it. So also we need to know that the clean media to store the copies. When you copy, don't copy into something which is already infected, corrupted. Maybe that hard disk not good. So don't try to use that. Yeah. And third one is, try to always keep 2 or more copy. One is called working copy. Other copies were library controlled copies. Okay. So later on, if you want to disclose the purpose or in event of that working copy gets corrupt. So now imagine now you have one copy, original one. I take a copy for my analysis. Also, I take another copy for library control. Okay. So that is how it is stored. Then upon creating copies of original media, verify the integrities of the copies. That means you can do the integrity check. Like you can check the file type, file size, if it is if it has something like HMAC or encryption, try to see that file encryption. Make sure that the file I copied is not altered during the copying process or is not changed during the copying process. Or if I've not missed any specific file inside a folder during the copying process. Okay. So that is one. Then, so you hope understood the data acquisition fundamental, right? So what are the two type of data acquisition? Can type, please type it. One is live and debt. Very good. Okay. Very good. So let us get into some example of live data you collect. Can you give? Can you give an example for live data and dead data? Yeah, RAM, not hacking. Live data is nothing but your network routing table, all right? Your memory, your CPU utilization, the user who was logged on, user who has logged into the system, all of them. Storage, yeah. Debt is storage, all of them are, yeah. Cache is one part of this, live data, exactly. So now let us get into types of data acquisition. What type of? So we call it as something called logical and sparse. So logical means it helps the investigator to capture only the selected files or file types of interest to the case. For example, if I have 1 GB of data, maybe I need only video files. The video files, if you look at it, it is only 100 MB. So should I copy the entire 1 GB or only the 100 MB of video file? Which one I will do? For my case, only I'm looking for videos. So I will I should only collect the videos, all right, 100 MB. So like outlook.pst, OST files, writes are collecting specific records. Then another one is sparse acquisition, similar to that, but in addition to the specific file type, you also collect fragments of unallocated data, allowing investigator to acquire deleted files. Why do you want to collect the fragments of unallocated data? Because that's where you can recover the files which are deleted. Once you delete, these are all the spaces will be empty, but you can, recover. If you are copying that area also, it could help you to recover the deleted files. So use method when inspection of entire drive is not required. It's called sparse acquisition. Is it clear? What is sparse? Sparse is the specific video file plus whatever has been deleted. Means I know that there is a fragments of unallocated data. I also want to copy because this could be used later on when I want to do investigation. I want to see what are the files deleted. So using that space, I can recreate the files which were deleted. Does it make sense? Yes, no? Type in the chat box, please. Very good. So bitstream disk to image file, the most common method used by forensic investigator. The created image file is a bit by bit replica of the suspect drive. So it is a bit by bit. Like tools used is to copy that, you cannot just copy. You need to use like ProDiscovery, InCase, FTK, SleuthKit, which we already saw, right? Last time we saw about SleuthKit. Then we also talked about X-Face forensics, all of them. And bitstream disk to disk, when you want to do, it is a disk to image file. It is like copying as an image, bit. But if you want to take it as a disk to, bitstream disk to disk. So disk to image file will not be possible. Like a situation like where the suspect drive is very old and incompatible with the imaging software. So the drive itself very old, am I right? And also he has to recover credentials used for website and user accounts. So then I also want to get all those data which is stored. Okay. So to overcome the situation, we can create this to this bitstream copy of the darkened media. So what happens? I can adjust darkened geometry like head, cylinder, track to align with the suspect drive. This results in smooth data acquisition process. So we use tool called Encase, Tableau, Forensic Imager. Right? These are the things which we can use. Encase can be used for bit disk to disk or disk to image. Both cases you can use that. This is the tools you need to use. So now third one is determine the data acquisition format. What type of format I need to acquire? The type of format is called raw format. Raw means what? We know raw data. What do you mean by raw data? You don't copy as a video or something. No, you say bit by bit. It is like images in this format and whatever. You are usually obtained like DD, disk to disk copy, DD copy command in the command prompt. Fast transfer, source drivers, minor data read. Minor data readers on source drive are ignored, read by most of the forensic. It was read by most of the forensic tools. But the disadvantage is what? Requires same amount of storage. If you're copying 1 terabyte, you need a 1 terabyte, the hard disk at the destination. And also sometimes if you have a bad sector, bad means it is, in the image, there are some, location which is corrupted. So some of the open source may, fail because of the bad sector. But if we are using some tools, they can, paid tools, it can copy that. So proprietary format. What is that? Commercial forensic tools acquire data from the suspect drive and save the image files in their own formats. All right. So why? Because it can compress the data. So save space on the target media. If it is like 100 GB. So if it is 100 GB, you don't have enough space in the target media, then I will use in a proprietary tool format to compress that. Yeah. And ability to split an image into multiple segments. So in order to save them in smaller target media such as DVD, for example, when you copy, you can put one let us say 100 GB file, you can make it into, let us say 101 GB DVD players. So it will become 100 CDs. And also ability to incorporate metadata into the image file, which includes date and time of acquisition, hash values of the file, case studies, etc. Case studies, etc. What is the disadvantage? Once you use one tool, you have to use the same tool. It may not be supported in the another tool. Okay. So advanced forensic format is something which is an open source acquisition format. With the goal is what? No size limitation. First of all, it's a simple design. So it can be accessible through multiple computing platform and OS, like you can use for Windows, Linux, Mac. Internal consistency checks for self-authentication to make sure. Also, it can record metadata. So file extension looks like .aff, AFF metadata, and AFD for segmented image files. This is a different format, data acquisition format. Okay. There is another framework called Advanced Forensic 4. What is that? Redesign and revision of AFF. Use large amount of disk images. That is one thing. So it can reduce the acquisition time. Then second one is, it also basic type of is volume, streams, and graphs. Then usually reference through a unique URL. So you can put a URL and say, this is the data. So it also allows storage of this image data. And also, more kind of organized information in the evidence file, offers unified data model and naming scheme. So these are some of the format which could help you in the long term when you are acquiring a data and you want to use advanced formats so that you can save some space. So let us get into the methodology. Before I get into methodology, somebody is asking, sir, where can we get the PPT? I think the PPT was shared. It is there in the drive. I can ask Tahir, maybe it is there in your description. Go and check it. You will find it probably. Otherwise, I will ask Tahir to again share it. You can download. Okay. So can you explain an example of data recovery from Delta files in USB drive? Yeah, this was we have seen the last session. Am I right? So please watch the last one. We have done with the hard disk. Maybe you have to use different drive. Maybe select the source from hard disk to USB. Okay, fine. I'll ask Tahir to share it if it is not available. So what is the methodology? You need to determine the data acquisition method. What is the tool I'm going to use? Before I copy to the target media should be sanitized, means it should be clean. Okay. Then I check if the computer is on or off. If on means, what did you call? It is a live acquisition. What I do in live acquisition? What is the live acquisition? You can take volatile data and turn off the computer. It's already turned off, then remove the hard disk, write, protect the suspect device, acquire non-volatile data, plan for contingency, means you take multiple copies, right, and validate the data acquisition. These are the methodology we need to follow. Okay, so let us start from one by one. Step one. No problem. If you're not able to, we will share all the previous PPTs and also the recordings. Okay, don't worry about that. So determine the best data acquisition method. So you need to say where you want to do. The investigator needs to identify best data method. So like size of the suspect drive, time required, maybe it is very big, then it may require hours sometime. Maybe some small data it can take within 10 minutes, 5 minutes. It depends upon the size of the file I'm looking for. So in case of original evidence, drive needs to be returned to the owner, as in the case of discovery implement of civil litigation case. Check with the requester whether the logical acquisition of the disk is acceptable. Means I don't take everything, but I want to take only video. Do you agree with that? If the lawyer or supervisor say it's okay, then you can take only the required data, or you have to collect the entire data. And also you need to only acquire the data which is required, not everything else. Or we want to look for some evidence, look for that particular evidence file. Maybe it could be a Word file, video file, or a JPG image, but don't go and look for something else which is not, you are not allowed to check. Okay, you need to be very careful. Then select the data acquisition tool. What is the original content, log IO errors, then the tool you are using should be having a scientific and peer review. It should be a very good tool, because taking the right tool for data acquisition is very important, because that is going to decide how accurate is your evidence going to be in the future. Yeah, because if you copy with the proper tool, it will make sure all the data is copied and you can do the investigation. Yeah, so selecting the tool. Third one is sanitize the target media. So if you have some kind of a problem, something is broken, try to clean it. All right. Post investigation, they must dispose the media by following same standard so as to mitigate the risk of unauthorized disclosure of information or ensure its confidentiality. So the following are some standards of sanitizing media: Russian standard, German standard, American, NIST. So NIST is called SP 888. Then you have acquire volatile data. If it is live, volatile data is involved collecting data that is lost when the computer is shut down or recovered. So the data usually correspond to running processes. Who is logged in? Am I right? Any DLL is running parallelly. These are the information we can take it. So Belka software live RAM capture is a forensic tool that allows extracting the entire contents of a computer's memory. So just if you have this software, it can dump the entire memory from volatile memory into your destination disk. Like it saves the image file in mem format. Okay, just a minute. Okay, then this is the one of the tool which can be used to collect or take the volatile memory. Okay, extract the information. Then write protection on the evidence media. It is necessary to protect the suspect drive using a write blockers. Have you seen this kind of jumpers? Have you noticed? Just 1 second. Have you noticed such kind of things in a hard disk? Yeah, we call it jumper setting, right? No, I think most of you should have noticed this if you are working in a hard disk. Yeah. So this is called kind of a jumper setting. Why? There's a drop. Okay. Can you see this? This is called jumper, right? So if you change the setting here, it will protect anyone to write data. So you don't want to accidentally write something into the hard disk because it can create problem for you. Okay, so you don't want to do that. You understand? So this is the area which we are talking about. So you have to create something called write protection. Okay. Fine. Yeah, jumper setting, exactly. So then it blocks write command, thus allowing read-only access. So that hard disk you brought even by mistake, you will not write anything into that. So hardware write blocker is used. Install a write blocker device, boot the system with the examine controller operating system. So like CRU, these are all the Tableau forensic bridge, etc. If software write blocker is used, boot the system with the examiner controller operating system, activate write protection. So you can use safe block, Mac forensic lab, write controller, etc. So these are the different tools available. Then acquire non-volatile data, like acquire data from a hard disk, right? There's no significant difference in the amount of data acquired from hard disk between live and dead acquisition method. Both are same, whether it's live or dead. But live acquisition of hard disk is performed using what? remote acquisition tool like Netcat, maybe bootable CD like Kane. And while data acquisition involves removing the hard disk from the suspect device and just connect to the workstation. So you can just copy that, all the information. Okay. So we use Windows Forensic Workstation. Using Windows Forensic Workstation, what we do, they acquire the image of a hard disk during the data acquisition. Then what they do, they remove the hard disk, connect to the. You remember we said as one of the main objective, one of the main step we have to do it. What we need to have something called forensic workstation, am I right? So it will have write blocker, and also it should have a forensic imaging tool like access data, FTK imager on the workstation. So once you connect disk imaging program, which can preview recover data from a disk and any kind of and also it can create copies called forensic images of the data. So you need to connect it and create copies. Can you check this? So it also check the once it's copied, it is also check the integrity. For example, is both of them are same or not? Yeah. So I want to know whether the one which I have collected this information, is it same or not? I want to understand. Okay, so that is how it will be created. So once image is done, make sure this hash values are matching with the one which you have copied. So why do you need to match this hash value? That is how you will make sure the file is not, altered or changed. Okay, is it clear? Yeah, okay, very good. Then plan for contingency means make 2 images of the digital evidence collected in order to preserve it. And also you can use imaging tools like, for discover, forensic or access data, FDK imager, because this can do first image with one tool. So first image with one tool and the second image with the other tool. So if you possess only one tool, then you can do with only. So why do you want to create with 2 different tools? In order to make sure that even if there is a problem, you can use the other one. All right, if something happened. So these are the different one. Digital evidence, first copy of digital, second copy. Both of them are important. So plan for contingency, you can consider what? Using something called so you can consider using hardware acquisition tool, like these are some of the tools to access the drive at the BIOS level. Okay, to copy the data of host protected area, because most of the information related to the host, some of the host protected area, BIOS level, you need to copy. If you want to copy, you need to use a different tool like UFID Ultimate, all these tools. Then also you have to do device decryption, pre-prepared with encrypted drives. So the user to provide a decryption key. Microsoft include the full disk encryption feature with select edition of Windows Vista later. All right. So you have something called disk encryption and decryption. So if it is encrypted, what is required? You need to get the decryption key. Am I right? Yeah, decryptor, exactly. So volatile data acquisition, it involves calculating the hash value of the target media, so which we already talked about it. So it is something called um, yeah, hash value, that is very important, am I right? Of the target media. Then also unique number. So the hash value is referred as digital fingerprint. Yeah, because the one you copied or one the original file is called digital fingerprint. The hash values are unique. If two files have the same hash, they are 100% identical, even if the files are named differently. So that is how when we are doing malware analysis, we will see it later on, we don't copy the entire file into virus total. Rather, we take the hash value, we go and paste it. It will tell you this file is virus or not. It is a worm or not. You got the point, am I right? So hash values are very, very important in digital forensic. So utility algorithm that produce hash values are, you have this all these tools, you can use it to create a hash or to check the hash and later on compare the hash once you copy the data. Fine. So we are coming to the almost toward the end of the session. So validate. How do you validate? In Windows, we comes with the PowerShell utility, right? So which has the ability to run command let. So it like the get file has CMD, let compute the hash value of an evidence file by using the specified hash algorithm. So if you do that get file hash and the particular file algorithm MD5, so it's a MD5, what is the hash value it will give you, right? And hash value is used throughout the investigation for validating the integrity. So please always remember, I'm going to repeat this again. It is more important for us to understand that you always have a digital fingerprint, which is called hash value. That is the only way we can know that the integrity of the evidence is preserved or validated. Okay? Just now. Okay, so investigator can also use commercial computer forensic program. They will also use built-in validation feature that can be used to validate the evidence files. So just we need to now give a focus here that there is something called hash file, that is required hash value that is important for the investigation for validating the integrity of the evidence. So if the hashes do not match, the tool notifies that the image is corrupt. That means what you have copied is corrupt. So do it again, before you do anything with the original data. Okay. So tomorrow you cannot say that this is the original data. I can produce evidence using this in the court. So you need to be very careful about that. So that is all for today. We have covered some of the core concept, okay, of what is data acquisition, why do we need, and what is called dead, volatile and dead, right? And sorry, live and dead. Also, we talked about what are the different formats based on the tools. The formats differs. Maybe you can also select only specific file required. So we also talked about the methodology, step 1, 2, 3, 4, 5, 6, 7, 8. All the steps in clear methods. Right? So can anyone take a screenshot of this picture and post it in your LinkedIn or whatever you want to do? This is something very important. Can you take a picture? Tahir, can you take a picture and post it in our group? Okay. So we'll give you all the recordings. I think you need to connect with Tahir and he'll help you. So far, is it clear? All of you are able to follow this? If you are okay, then I'll move on to the next one. Let me see. Okay. Any questions? So far, everything is clear. See, virus and worm, how to detect that we'll see later on, but you need to first copy the data, right? Here we are only collecting the data, not analyzing. Is it clear for you? Are you able to understand? The process is only here to collect data. Yeah. Can you see my screen? All of you? Let me get into the lab. Is it visible? Very good. So what we are going to do, how to data acquisition duplication. How to do that? I'm sorry, it is so here we are going to create a DD image file, converting image file to bootable virtual machine. So you can boot that, memory acquisition of Windows and Linux workstation, extracting the hidden content from the hard disk. These are all the things which will be learning. Okay. So let us go into the first one is creating a copy. Just 1 second. Is it okay now? Yeah. Fine. So, okay. So that's what we are going to see. Let us see the first one. The first one is to create a image of the system drive, right? So in the lab, what we are going to do, we are going to create a disk image. So let us log into the system. It's like we are using bit by bit copy of the hard disk. Disk image is the command which we can use, DD command. Let me go to the Windows system. Let me log on to the physical drive. In this lab, we'll be, physically doing that. Let me go there. Okay. So DD is that command. Let me go copy. I'm pasting the tool. DD. Okay. Is the folder. I'm going to go to the PowerShell. There is a PowerShell which you can do a lot of scripts under that Windows PowerShell. And I'm going to run the command call. 1 second. I'm checking. Is it visible? 1 second. So I'm saying we make disk drive list in brief, and then I'm also copying that. I'm right CD, and then I'm also saying error writing the file. Okay. So now I created the file into a particular folder. So once the file is copied, that means you have the image taken from a particular hard disk, right? So the commands, it depends. Like for example, now what I did here, I'm trying to do with CD, C colon. Okay, C colon is the desktop, DD is fine. That is where I'm going to, I change my directory to that particular folder. Okay. Then I'm going to run a command. What is the command? .dd.exe. I am running a cell, PowerShell, .dd.exe. If I'm saying physical drive 0 of Windows environment, this is the command, then I'm saying bitstream is 512K. So start copying it. So this is how you can create a file. So at the end of the program, once you copy it, it says upon the number of records and number of records out is shown in here, am I right? It says how much it is copied. And you can also go and check the file in the forensic file ID, Windows evidence disk 0. Okay, is it clear for all of you? Just created this copy. Any questions? Let me move on to the next one. So we copied an image, but I want to make it as a bootable image so that I can bring it to my system and boot it as a VM. Okay. So what I'm going to do, so investigate from data acquisition of suspect machine in a forensic sound manner. So virtual machines runs a dedicated OS on a shared physical device. Okay. What is the objective? The objective of this lab is to help you understand how to convert a image file into a bootable virtual machine. Okay. So we created image, but I want to create it as a bootable virtual machine. Okay. So let us see that, how I can do that. So I'm going to the Windows server, sorry, Unix server. Fine. I got in, then I'm going to run something called type clipper text, sudo apt get install GEMU utilities. I'm writing it. Sudo, I'm giving the password. Okay, it's running. Sorry, it is installing the. Yeah. Okay, I'm installing the GEMU utilities. Let us see. It's running. Yeah. Okay. Install. Yeah. So this is a virtual machine. I'm in the virtual machine. So let me take the image which I copied. Am I right? Created the disk. Yeah, evidence file, forensic images. I open terminal. Okay. Yes. So I'm trying GEMU image convert raw Windows evidence into a VHDX, means it's a Windows VHDX. It's a bootable image of virtual image. Okay, I'm trying to create that. GEMU is the tool I'm using for converting an image into bootable Windows virtual machine. Okay. It is converting. I copied all the commands. So now it's created. Can you see this? Windows VHD. So if you are okay, assuming that the platform used on Hyper-V, we shall convert DD image into VXTS. That's it. So you have now converted that into VXTS. So you copied image. Now you convert that into a what? As a bootable image. Is it clear now? The second step. Yeah. All of you, please can you type? Yes, very good. That's wonderful. Third step. Now we are going one by one. Okay. Now what I'm going to do, the step is acquiring RAM from Windows Workstation. So I want to get the RAM out of Windows Workstation. Am I right? It's like dumping the entire RAM so that I can do analysis, random access memory. So I'm going to use some tool called bulk soft RAM capture tool. Okay. So let me get into the tool. I'll go data acquisition tools, run it. Yeah. I connected it and then let me install the tool. Yeah. RAM capture. The 64. Let me run. I'm installing an application, nothing else. Okay. I'm installing Windows RAM capture. Yeah. Fine. Okay. I'm running the file. So it's running, loading the device to physical memory page size. Okay. It's running capture. Now I'm going to say that capture. It is going to capture and dump it in the folder which I created. So it's taking the entire physical memory of 9 GB RAM or 4 GB RAM and dumping it. Yeah. So I could run. So let me go to that. Yeah, you will find that in the top, right? So can you see that? Let me show you again. So this is the memory. memory dump. I took the memory dump of a particular file. Okay. So that is to just, so if you want to analyze your phone memory or any memory, then you can use it. Yeah. So is it clear now? So third step we did is very simple, straightforward. We just dump the entire memory for tomorrow for any, validation to analyze the files. Okay. So now I'm going to viewing the contents on forensic image file. That is what I'm going to do that. Okay. Viewing that in the forensic image file. So I am going to view. Okay. So what I will do, the objective is to forensic image, what is the forensic image needs to preview the content. So I created the content, I want to see what is there. Right? The objective of the lab to help students learn how to use access data imager for viewing forensic images. So that is our objective. Very good. So let me start. Okay. Let me get into the tool. I'm going to use a tool called access data imager to view data, image data. So let me install it quickly. Let me run. Yeah. Now the data imager is done. Now let me file, open, add evidence. Yeah. Add evidence item. Is it an image file? Am I right? It is not a physical device, it's an image file. Select a path. I need to go there, log image files. Yeah. I can select any of the image files. Let us say Windows evidence DD1. This is what I created before. Finish. So now you can see that I'm able to view what is there inside the image. Evidence is NTFS. Okay. Very great. Urban root. It has got images. Can you see that? It has other files, Outlook files. So now, without even loading the file, I'm able to see what is in the image file using a tool. I can go and click. It's showing the image like whatever the image you have, JPJ, all of them. Right? It also says the file when it was created. This file particularly. Okay. So it also gives the hex value. So that is wonderful, great. So what we have learned so far is something, what we have learned? We learned DD command to create an image copy. Then we used a tool to convert as a bootable Windows virtual machine image so that you can boot that, disk copy as an image file, from image file to bootable version of a particular disk. The third one, we did, what did we do? The last one we did was using viewing the file, am I right? Viewing the content of the forensic file. But the third one we did was dump that RAM of the Windows machine. Is it not? Is that right? So that's all from today, that we learned how to acquire data from hard disk, from RAM, how to view that, all of them we have seen with the different tools. I hope you enjoyed. Please leave your feedback. For sure we are going to share the documents in the group, but I think you need to enter your username, password, I think, or maybe you have to refer. I don't know what is the strategy. Tahil will share with you. But please make sure that you can learn this and also understand the lab. Okay. Did you enjoy today's session? What is your rating? How do you feel? Can you just give a thumbs up or give it in the chat box? How was the session today? Yeah. It's great. It is nice. Very good. Yeah. Very interactive. Yeah, we will do that. Share. We will share. Don't worry about that. Yeah. Priyadashini. Yeah. Okay. Okay. That's good. So we are going to share a feedback link. Please share your feedback in the LinkedIn. Okay. By the way, I'm also going to be in JTech in Dubai for next 5 days, 10th to 14th. If you are by chance anywhere living in Middle East, you are coming, attending the JTech, please meet me. You can, take my number or from Tahir. He will help you. So, if you want to meet, we are going to do some road. I'm going to be some kind of a speaker in the YouthX ambassador in JTEX. So you can meet me also there. Try to follow me in LinkedIn. I am also going to share the post in LinkedIn. Please like it, share it, and also make sure if you have anything you want to meet me, you can just message me there. Okay. Thank you. Thanks a lot, and hope you all enjoyed this session. See you next week.